Alright guys, this first video we are going to get into logarithms, okay, logarithmic functions. And this first one we're just going to go over the very basics. The main thing to remember is if you have a logarithmic function, it's basically you can rewrite it as an exponential function, but you just kind of switch around the x's and the y's. Okay, and we kind of talked about that before with inverse functions. If you look right here for the review, this is an exponential function where the a is the base and the x is the exponent. This is if I switch the x and the y. If we have a logarithm, this a, that little a right there is the base. Now, if I want to put it into exponential form, I circle this. This is the most important part. That's the base. So I'm going to say a, and I kind of use this to kind of help me. A raised to whatever that equals, so it's a to the y equals this. This x right here, that's called the argument. So this is the inverse of an exponential function. You can see, you can take a logarithm, you really just switch around the x and the y. All right, now if I want to evaluate logarithms, when I put numbers in here, it's probably going to make a lot more sense. If I use this fact that I can take a logarithmic function and change it to an exponential, I can evaluate these 8 problems. If I looked at number 1, let's say this is equal to y, and I want to solve for y. I want to evaluate it. The key part here is that the base right there is 2. All right, and I always kind of use this little circle method to help me remember which is the exponent. So I go 2 to the y equals the argument, which is this, 32. So what that problem's asking me is, all right, 2 to what power is 32? And since 2 to the 5th is 32, then the answer to this problem is 5. So 2 to the 5th is 32, so the answer is 5. Okay, if I did number 2, the base here is 10. So again, if I follow this little circle pattern here, this is saying, all right, 10 to what exponent equals this argument, which is 1 over 100. Now, once you see the argument is a fraction, that's telling you the y. It's going to be a negative. So I know 10 squared is 100, so if it's 1 over 100, then I make the y negative. So the answer to this is negative 2. Because 10 to the negative 2 is 1 over 10 squared, or 1 over 100. Okay, if I did number 3, okay, I set this equal to y, so this is like saying 3 to the y equals 27. I'm giving you all easy ones right now. So 3 to the 3rd, that equals 27, because 3 times 3 times 3 is 27, so that's the answer. Okay, if I did number 4, okay, I'm going to do, what, 4 to the y equals the argument here of 2. Well, this one's a little bit different because now the base is bigger, but the connection here is, since you can take the square root of 4, here, I'll write it right here. Since the square root of 4 is 2, that's the same thing as taking 4 and raising it to the 1/2. So taking any number, raising it to the 1/2, that's the same as taking the square root. So the answer for this, for y, is 1/2. All right, so you can see for all of these, we're just going to put it back into exponential form and solve for the y. I'll do the last 4 real quick. 5, 6, and 7, the one thing that we notice, make this even a little bigger, oops, is that the argument is 1 for 5, 6, and 7. So I'll have these grouped together. Now I'm going to do the first one. You should be able to see the answer for 6 and 7. So if I set this equal to y, this is going to be 3 to the y equals 1. Well, when we do exponents, anything raised to the 0 power equals 1. So the answer to this is 0. Now, 6 and 7 is going to be the same thing too. Like if I did 6, set this equal to y, I get 8 to the y equals 1. You can see the base. Okay, you can see that the base doesn't matter. The base is 8, and any number raised to the 0 is 1. So that's my answer. All right, I know if I did 7, I would get 11 to the y equals 1. Well, same thing. As long as the argument's 1, your answer is going to be 0. Okay, and that's going to be one of the basic properties of logarithms that we'll take down low. Okay, then if we did the last one, okay, the last one, the connection is, what if the base and the argument are the same? What is that going to equal? Well, if I set it equal to y, I have 6 to the y equals 6. If these are the same, then you should be able to see easily that y has to be 1, because 6 to the first power is 6. So this is y equals 1. All right, so main thing there, if you have a logarithm, you can rewrite it to an exponential, which will allow you to evaluate what it equals.